Sierra-Olympia Technologies is an infrared camera company, and Sierra-Olympia Technologies has been in the UAV business for a very long time, probably more significantly than most people realize. And I'll go through a few of those, or a history of the company, and why we're participating in this kind of event. We're going to talk about specific exciting cameras that are being used right now in the UAV market. We've designed these specifically for customers. We have active installations. They're somewhat special. I don't know if there's overlap with any of the audience members' applications, but we chose these cameras to give you some insight in the target technology and the scale of technology that we deal with. We're going to talk about a camera that's designed for the oil and gas business, specifically to detect methane leaks. We're going to talk about the industry's only full HD uncooled microbolometer camera. We have a product that we're working to finish called Ventus Micro, which is an extremely small, high performance, continuous zoom camera for ISR, intelligence, surveillance, and reconnaissance, designed for basically the smallest payloads that anyone's considering now. And then I'll talk further about latest of small pixel uncooled microbolometer technologies. And then I'll wrap up with some future trends that this industry can expect, just in general terms, and what we're keeping our eye on. First thing we're going to talk about is why are we here? So Sierra-Olympia was started in 1995, so we just celebrated our 25th anniversary. We have members on the team who've been in the infrared business since the mid-'80s. I was a young man with far fewer gray hairs when I started in the infrared business. And believe me, the people on this team have very long experience with infrared focal plane arrays. The staff is over 30 people, and we're hiring all the time. We grew by 11 persons last year, and heavens, we've probably hired 5 or 6 people so far this year, and we're always looking for talent. It's been a very rapid growth period for us over the past couple of years. The company is ISO 9001:2015 certified. We do everything under a management system to ensure quality products for our customers. And we recently moved into a new 22,000 square foot facility in our hometown of Hood River, Oregon. We're right on the Columbia River. Behind me, you can see our ISO class 5 clean room, and then the stations in there are rated ISO class 7. It's a pleasure to be here in Hood River. People will probably figure out that we've grown with the Hood River UAV community, and Hood River, Oregon has grown to be a technical hub for this business. We were lucky enough to be in the early stages of deployed UAV systems in the early 2000s. And everybody knows what happened in the early 2000s right after 9/11. There was a tremendous demand for UAVs, and we had the right cameras at the right time, and we were selling as many cameras as we could make, primarily installed in tactical UAS systems. Our heritage is military UAS. The company has always addressed military customers, industrial customers, commercial customers. We have a broad range of technologies, and but most of our growth and most of the start of our business in UAS started in the early 2000s with the military business, particularly here in Hood River. We've sold over 3,000 special uncooled systems. Most of the systems that we do are not your typical commercial uncooled system with a single field of view lens. We have special configurations, special processor interfaces that go with our systems that are tailored to meet the needs of the particular client building the airborne system with the uncooled microbolometer. And back in the early 2000s, microbolometers were still somewhat exotic. A VGA resolution microbolometer camera was a $20,000 unit. The lenses were very specialized. Certainly 20 years later, leap forward to today, the technology has matured and the cameras are much less expensive now, but that's technology. We've always been involved in cooled midwave. Our activity with cooled midwave goes pretty much started kicking up around 2008. And there were reasons for that having to do with the applications, but fundamentally we leapt from the uncooled longwave cameras to the more exotic, more powerful midwave cameras almost overnight. And since 2008, we've probably had over 3,500, probably approaching 4,000 cooled midwave systems deployed on airborne platforms. We have also tremendous experience. We've grown up with continuous optical zoom lenses. The earliest optical zoom lenses we purchased, integrated into cameras, and deployed on airborne systems. So we've seen continuous optical zoom thermal cameras, which really is something quite new, perhaps only since about 2008, when they were widely deployed. Where do we stand right now? We have a bunch of customers in the airborne business, and we're a reliable technical partner for the core infrared imaging technology that goes into an airborne system. And so what we can do is deliver an infrared camera that has a consistent spec. It's built with quality in mind. It's designed, it's lightweight, and we deliver that to the customer, and then they can focus on the gimbal. So we have a number of customers where that is our position, and that's what we provide. It's not our only business. We have a number of businesses across the infrared arena, but this is about UAS, and so we'll stick to that application. Okay, so now let's move on to cameras. The first camera I want to talk about is Ventus OGI. That's this camera right here. So let me get my ESD strap on. What is Ventus OGI? Ventus OGI is a cooled midwave infrared camera. You can see the cooler right here. It is specially designed for one application. It's designed to detect fugitive emissions, primarily methane. In the oil and gas business, there's a big problem in that we have lots of natural gas, lots of drilling for oil, lots of methane leaks. Methane is a very bad greenhouse gas. It's amongst the big three in greenhouse gases. When you think about climate change, it's transportation, methane leaks, and farming. So this is designed to detect methane leaks. How does it do that? Methane is a CH4 gas. It has a particular absorption spectrum, and it is we install a filter in this camera that allows us to see the absorption characteristics of the methane. And what it does is the methane has strong absorption around the particular filter wave band, and it and when it's leaking, it looks like a dark cloud, and it's very particular to the methane. This application has been around for 15 years or so, and most of the work in methane leak detection or optical gas imaging, that's our particular area in this arena, is done by handheld. So there's a family of handheld cameras, and teams walk around a gas plant or travel for miles out to drilling rigs and mining sites where they drill for natural gas and oil, and they try and detect leaks out there. We recognize that there's a need to do this from an airborne platform. A typical midwave system is, I don't know, 5 pounds, 2 kilograms, 3 kilograms. It's a big handheld system. So what we did is worked with the sensor vendor to develop a very small sensor that is suitable for use on the multi-rotor class UAVs. So we focused on small size, small volume, low power, and lightweight. And that's difficult with these coolers and everything. It's usually these cameras are much larger, but the expense and the difficulty of creating these cameras for lightweight is where we focus. It's again, this is designed for the multi-rotor market. And we have some important clients that are installing these on the most powerful multi-rotor systems and the most popular multi-rotor systems, and flying them around in various locations where the concern of natural gas or methane leak detection is tantamount. And so with increased awareness about this and the necessity to control those kind of emissions, that's where this camera fits in. So it's a camera that we offer to everybody, and it's designed for integration. There's no power switch. It's lightweight. You can see that the camera, all the connectors, all the signals come out on these small pico blade connectors. And what do we do here? We integrate everything into this so it behaves like a camera. Most of the industry deals with lenses and sensors and leaves it up to customers to figure out the camera part themselves. So we step in, we work with the sensor manufacturers, which is difficult enough unto itself. We work with the lens vendors to customize lenses for the applications. In this case, we designed a lens that's extremely lightweight, optimized for lightweight, optimized for the sensor, and came up with this package, tied it together with custom electronics and video processing. So basically, this is a 640 by 512 midwave infrared camera with very special filtering for methane. The weight of this is only 540 grams, only a little more than a pound. We have a lens. It's a 25-degree lens. We're working on other lenses. Lenses are difficult, waiting for customers, but this 24-degree lens is right in the sweet spot. I think you're seeing a video right now of what a customer sees from the air. That's actually a picture taken from a drone customer of ours, and just a typical picture of what leaking methane looks like. Features also include onboard digital storage. It's got digital IP video, so it interfaces with the aircraft infrastructure very well. It also has powerful image processing modes that allow for enhancement of the gas. We've come up with a custom proprietary gas enhancement mode that kind of highlights the faintest gas leaks. It highlights everything in the scene, in fact, but in particular, it works well with the leaking methane. So summarizing about this camera, again, special midwave camera. I can't say it's low cost. It's not low cost, but it solves a very important problem related to climate change, and that's helping to find methane leaks efficiently from the air. We have customers in the small multi-rotor market. We have customers in the manned multi-rotor market. So Ventus OGI, that's this camera. So now I'm going to move on to the next camera I want to talk about, and that's the Vayu HD. What's special about Vayu HD? Vayu HD is the industry's only full HD uncooled camera. We've worked with the sensor vendor for many years here and have come up with a lightweight product. This is our first version of the camera. We expect to come up with other versions of the camera, but for those who want 1920 by 1200 resolution, you know, VGA I was speaking about over here is 640 by 480. This is 5-6 times the resolution, 1920 by 1200. You can see that it's constructed in a similar way with the industrial or the common Pico blade and Sherlock connectors. We have a common processing base that allows us to offer a lot of similarity across our product line. IP video, HDMI, SDI outputs, onboard digital storage, it's all here as well. Now, what are the difficult things about this? So, Vayu HD, like I said, we've been working with the sensor vendor for many, many years. I think it's going on 5 or 6 years now. This is the sensor. This is what we get from our sensor supplier. It's a monstrous sensor, you know, 1920 by 1200 by 12 micron pixels is a 27 millimeter diagonal. That's over an inch. In the infrared world, there are no lenses that are designed for this size of sensor. So every time we build something here, we need, and a customer needs another lens, we have to figure out how to build that lens or work within the very limited selection with what we have available in the market. All other sensors are far more common. You know, in midwave, 640, 512, 15 micron, there's probably 20 or 30 lenses, good lenses that you can choose from. In the uncooled world with 640 by 512 by 17 microns, lots of lenses, 640, 512, 12 or 10 microns. Not as much, but a lot of lenses. For this sensor, no lenses. So everything has to be custom. So this particular one is a 50 millimeter we've developed. We've worked on, we have a 25 millimeter as well, and hope to have a 100 millimeter. And then there's a smattering of other lenses that we can get that are suitable for this. So what's the benefit of this technology? Basically, it's just superior resolution. And what you're looking at on the screen right now is what an airborne application with this camera looks like. In 2019, we participated with NASA on a project where we got this installed on a stabilized gimbal for a helicopter application. And they wanted to get ground truth data on a number of key points around Los Angeles. And so we were able to collect hours of video data just flying around Los Angeles. And you can see some of this data or some of this imagery. And, you know, for an uncooled microbolometer camera, with the resolution that is unmatched everywhere, produces truly superior video. So what are some of the applications for this? Mostly we're finding that our customers are using them for navigation purposes. The large aerospace companies have a bunch of platforms where they just want to provide the best nighttime visual data for the pilots. They want wide field of view and they want high resolution. And so that's what we're finding with this technology. We have most of the big names considering this kind of technology in one format or another. We've also been asked to do a number of somewhat special projects with this. A special project recently was to combine it with a big zoom lens that a customer had or customer identified. And we were able to put that together with them. So it's a specialized kind of lens, kind of a one-off technology, and we were able to put that together for the customer. So I think we have some video running of that right now. So this is off of our third floor looking across the Columbia River. And so the benefit here is just an extremely wide field of view. The other side of the river is probably a mile wide there. And then be able to maintain that resolution and zoom in. It's about a 6x zoom, almost a 6x zoom. And then another benefit with this is you have 1920 by 1200, you're zooming in, you reach the maximum zoom, and then you can start digitally zooming. You know, our electronics support up to 16x zoom. So you zoom in optically, and then we have smooth, continuous zoom into very narrow fields of view. And that's a benefit for that. So Vayu is new. It's been around, I don't know, 6 months or so. And we're taking orders and delivering systems right now. And most of them are airborne. I can't say if we've had unmanned systems yet. I think most of the systems we're looking at are manned systems so far. But, you know, I'm sure there'll be some unmanned systems coming along soon with this camera. Okay, so let's jump back into the midwave. Another camera that we're finishing up right now is this camera. It's we call it Ventus Micro. So this is designed for the ISR market. Ventus Micro is a small midwave camera with a continuous optical zoom that can get down to that narrow 2-degree horizontal field of view. That's kind of a sweet spot in the ISR business. So of the 4,000 midwave cameras that we've shipped, at least 3,000 of them have been with the continuous optical zoom through this range, 2 degrees notionally to 25 degrees. So being able to zoom in and zoom out from a tactical platform, and from a kilometer and a half away, you can zoom into about the field of view of a tennis court. And honestly, this is mostly a military technology, and being able to zoom into that that horizontal field of view gives you the ability to assess human intention. So it's very important for military applications. So what's special about this camera? It's a very common camera, meaning common technical attributes, for example, being able to zoom down to 2 degrees. However, the problem is we had to design this for a target customer that needed to fit it into a very specific volume, notionally about 150 millimeters in diameter, or a 6-inch gimbal. So a 6-inch gimbal is about this big. We had a very limited volume that we had to design all this performance into and allow this technology to articulate around in that 6-inch volume. So how is this done? First of all, it's a 180-degree lens. You can see that the lens light comes in here. There's 2 mirrors, it bounces, and the sensor is actually looking this way. So the light is actually bent. With this focal length, if you unfolded this, it would be about this long. And you wouldn't be able to fit that into a 6-inch diameter. So that's an exaggeration. There's always tricks you can do, but even the best optical designers can't get a straight through 2-degree horizontal field of view with the currently available sensors in this 6-inch volume. So we worked with the lens vendor to get this this lens design, 180 degrees, 16 to 180 millimeters. The sensor is somewhat unique in that it's 640 512 by 10 microns. The 10 micron pixel gives us an advantage. As pixel sizes decrease, you're allowed to, or you get the equivalent resolution with lower focal lengths. So that relieves the requirements to design with big focal lengths to achieve that 2 degrees. You know, formerly it used to be about 275, 300 millimeters with a 15 micron. You can do the same thing with 180 millimeters and a 10 micron pixel. The attributes of this camera are pretty much the same as the other cameras. We do IP video, we do analog video on this one, single power supply, supplying all the requirements for a fan, for the lens, for the sensor, for the cooler. This is a midwave system. We start with a sensor that looks like this. You can see that the midwave sensor has its doer and its compressor, and you know, we're very close to the sensor manufacturer when it comes to the design of these attributes. We were one of the earliest customers for this, and then the trick is getting. This is pretty much the lens and the sensor, and then the electronics and the power supplies to make everything sync. You know, we do all the autofocus, we do continuous autofocus, image enhancement, calibration, all the things necessary to put the sensor and the lens together to make it work as a system. So that pretty much sums up what we do day by day when we work with both the optic side and the sensor side, and we take the pain out of it for a customer, because, you know, gimbal manufacturers should focus on gimbals. We focus on infrared cameras, and we can help the gimbal manufacturers with the problems they face here. All right, so that's Ventus Micro. Pretty stable now. We're happy with the performance of the lens. We're happy with the performance of the sensor. We're still perfecting it, and you know, we have interest from customers for a number of applications for this. All right, so let's go back to Uncooled. So we talked about Uncooled, and we were boasting about our Vayu. Vayu HD is an uncooled camera. So, you know, in the infrared world, it's dominated with uncooled sensors. Honestly, you know, the cooled sensor market's very small. It's important for us. We're kind of specialized, but, you know, the quantities are very low compared to what we see in the world of uncooled sensors. And what we do you know, the bulk of uncooled technology is, you know, there's sensors as low resolution as 60 by 80, 120 by 160, and 320 by 240. You know, that's where the industry goes. It's super low cost when you go to 160 by 180 or 60 by 80 or 80 by 80. There's a lot of sensors out there, and a lot of applications are just fine with that low resolution. We tend to focus on 640, 480 and up. We have almost no customers with 320 by 240, and I don't want to dismiss that market. It's a very important market, a lot of great products out there. It's just that our specialty is getting the maximum value out of VGA resolution on hub. And so what do we have here? These are the tiny cores that we start with. Most vendors just give you something that looks like this. No lens, sensor on top, and then, you know, here's a digital connector. And, you know, it's a board-to-board connector. So even to talk to this kind of sensor, you have to drop on design your own boards and then route that sensor information to, you know, some kind of signal processor to make it available to a customer. And we do that across a number of platforms. You know, for years, you know, we were selling items that pretty much adopted this kind of technology. Sometimes they had analog output, but for years we've been adopting technology that's VGA resolution starting with 25 micron pixels. And then there's been a long period of time with VGA resolution and 17 micron pixels, and thousands and thousands of systems have been sold with VGA resolution and 17 micron pixels. Only in the past 3 or 4 years have manufacturers started going to the smaller pixels. Smaller pixels are 12 microns, and then even 10 microns are now becoming available. So this is an early sensor that we've had for 2 or 3 years with a 12 micron pixel. This is the first sensor that we started integrating with 12 micron pixels. So what does 12 microns buy you? When I put it behind any particular lens, the field of view is going to be narrower with a 12 micron pixel versus 17 micron pixels. So we have focused on those kind of activities for a long time. Finding the smallest pixel sensor and putting the available optics in front of it so that you get narrower and narrower field of views. That's what happens when customers want to see further and further away. You need a narrower and narrower field of view. So right now, 12 microns is kind of standard in the industry. So the exciting thing that's happened in the past couple of weeks is we've gotten the first versions of a 10 micron pixel. This is a product called Tenum. It's 640, 4.8 or 640, 512 by 10 micron pixels. You can see in this case, it has a lens on it. That's an advantage because it's a lens optimized for the 10 micron pixel. It comes from the manufacturer calibrated through the lens, which is a benefit to us. We have to do those kind of calibrations ourselves with a sensor like this. You can see it's the same kind of digital connector designed for board-to-board interface. And so you take, you have to design the boards that pop on here and that absorb the signals, route it to the processors, generate standard video outputs, whether it be IP video, whether it be transmitted onto a processor, whether it be USB or DVE or even analog video. You know, there's always a board that needs to go on here that translates the signal for regular use by standard interfaces. So what are some of those interfaces? We have boards that go on here that do USB video, with the UVC compliant data. You can put our boards on this sensor and it'll pop up like a webcam. We have a gigabit Ethernet, GE Vision standard interface to this, which is a standard for the machine vision business, but it's full bandwidth and a standardized interface supported by a number of different acquisition systems. You can do the old-timey camera link. You can do the old-timey analog video out of this too. The number of lenses available here is, depends upon field of view. The fields of view range from perhaps 6 degrees to as wide as 90 degrees. That's what, but it's a single field of view, and you purchase one camera and one lens in this class of camera. We have a range of cameras that are hooked up to zoom lenses, and none of those are in this presentation for this class of camera, but those are available as well. So in summary, with this technology, it's kind of new and novel right now to have this very high performance uncooled microbolometer core with 10 micron pixels. It's the smallest uncooled microbolometer pixel. And theoretically, I don't think it's ever going to get smaller. I don't see people making pixels smaller than the target wavelength. Longwave is 8 to 12 microns. Take 10 micron as the center wavelength, and there's no reason to build a pixel smaller than that 10 micron wavelength band. It'll be difficult to resolve. That goes into some heavy physics. So new, available, relatively low cost. It's priced competitively with other cameras in its class. It's very sensitive. The manufacturer here, DRS, has gone to great pains to ensure the highest possible sensitivity, raw, non-averaged sensitivity for this camera. And so, very new. We expect by summer this will be in full production. So I've gone through a number of camera technologies here, starting with the optical gas imaging, full HD microbolometer, a very small compact midwave for ISR, and talked a little bit about currently available VGA resolution microbolometers. And all of these are available and for sale by Sierra-Olympia. All of these are products supported on our website. All of these are products that we have a price list and a delivery schedule for. And we have a sales staff that's out there trying to help customers, fit things together and put things together in the right way for their application. Newest, of course, being this tiny new 10 micron pixel microbolometer camera. Some are specialized, like this customized thing for methane imaging, customized Ventus OGI for methane imaging, and certainly the Vayu HD is unique. I think I'll just wrap it up now and talk a little bit about where we're going in the future. So while I said that we're excited about this 10 micron pixel in the VGA realm, something new that we should expect in the future is HD sensors, not necessarily 1920 like this, but HD sensors with 10 micron pixels and 720p resolution, 1280 by 1024 by 10 microns, perhaps by the fall of this year. That's a new technology that we hope comes along and becomes commercially attractive. We see a good amount of interest in that intermediate performance between VGA and full HD. And it can certainly be smaller than the full HD, and the opportunity for more lens options becomes available when the 1280 by 1024 by 10 micron pixels. The diagonal of the sensor is not so extreme, and we can use a wider range of optics with such a camera. So in the uncooled world, we're on the edge with full HD. We're on the edge with VGA, and we'll be on the edge with 10 micron 1280 in 2021. In the midwave world, where we have to deal with these awful coolers and everything's super expensive, it's all about HD. And so we have probably 5 sensors in production that are VGA, and we're trying to figure out what to do next with HD sensors. HD sensors are available in 10 micron pixel is pretty much standard. There's an 8 micron pixel, there's 6 micron pixel, and pretty soon there's going to be 5 micron pixel. In fact, in the research class of camera, there's some exciting 5 micron pixel technology in full HD midwave that we're paying attention to. But probably the closest is the 1280 by 1024 by 6 micron or 8 micron pixels in midwave. So that's what we're studying right now, and we have systems outlined in our roadmap to go there. Coming back to Sierra-Olympia as a company, again, 30 plus people, we're growing. It's Sierra-Olympic.com. You can always get to us through our website. My name is Chris Johnston. You're welcome to email me. It's very simple. It's chris@Sierra-Olympic.com. If any questions have come from this, I'd be happy to answer any questions and help any customers with some questions they may have about items related to our technology. And then we expect to be able to post this video if there are people who want to go back and review it. And we'll probably break up little chunks of this to make them more digestible. We have an aggressive presence on LinkedIn. I invite you to check in on LinkedIn and see some exciting video there. And I invite you to visit our YouTube page because, heck, we're a camera company. We put videos out, we make video, and we're trying to post as much as we can on YouTube.